Okay, here they want us to solve the system of linear equations with decimal coefficients, and they want us to use elimination. So the first thing I'm going to do is actually get rid of my decimals. That way I can prep the system in order to solve by elimination. So I see that all I need to do is move the decimal one place in order to have whole integers. So I'm just going to multiply both sides of my equation here by 10, and this one also by 10. And that's going to change the look of the system a little bit. So instead of a negative 0.8, we're going to have a negative 8x plus 12y is equal to 60. When we distribute this 10 in, we'll distribute the 10 into this, to this, and to this. So you see 10 times a negative 0.8x is 8x, 10 times 1.2 becomes 12, and 10 times 6 is 60. So we'll do the same thing, distribute the 10, giving us a 32x minus 8y is equal to 40. Now we're prepped, or we can go ahead and prep the system in order to solve by elimination. Remember, all we need in order to solve by elimination is the same coefficient in front of the same variable. I look here, 8 and 32, not the same, 12 and 8, not the same. I can change these. I can change the y's to look the same, but I would need to manipulate both of the equations. I would need to multiply the top number by a certain number as well as the bottom. These both go into 24, so I could multiply the top by 2 and the bottom by 4, and we get 24y in front of both. Or you can see that 8 goes into 32. All we would need to do is multiply the top by 4, and we would have this prepped properly. So I'm going to go ahead and multiply again by 4 on this top one, and that will give us a negative 32x. And then 4 times 12 is a positive 48y. And then 4 times 60 is going to be 240. And then this equation stays the same, so we have 32x minus 8y equals 40. So now it's ready to solve via elimination. I can draw my line there. I see that I have opposite signs. We have a negative and a positive, so if I have opposite signs, I add the equations. So I'm just going to add the bottom equation to the top one, or actually what I'm instead of just adding the equation, what I'm actually doing is adding 32x minus 8y to the left side and adding 40 to the right side, because this expression is equivalent to 40. So I'm really just adding 40 to both sides, and that's why I can do this. That's why I can do elimination. So when I add, I have negative 32x, and combine like terms here. Negative 32x plus 32x, these eliminate. And then I've got 48 plus a negative 8, so that leaves me with 40y. And then 240 plus another 40 is 280. Then all I need to do is divide by my coefficient. And we have 40 over 40 cancels, leaving me with 1y. And that is equal to 280 divided by 40. And we see that the zeros would cancel, and then of course 28 divided by 4 is just 7. So if we multiplied, you can check your work, 7 times 40 should be 280. So once we have the y value, we would take that y value, we could put it over here, y is equal to 7. And we would plug it back into one of our equations. And it doesn't matter which. I could plug it into one of these two, or one of these two. So I'm seeing that probably the easiest one to plug this back into might be this one. Has the smallest numbers. So I'm going to go ahead and plug this in over here. Right here. And I'll plug it in there. So that'll give me a negative 8x. Plus 12 times 7, which is y, equals 60. So this will give us a negative 8x plus 84 equals 60. Then use opposite operation, subtract 84 from both sides, giving me a negative 8x. When I subtract 84 from this side, that cancels. When I subtract 84 from this side, I get a negative 24. Finally, divide by my coefficient, and I get x is equal to 3. X is equal to 3, and y is equal to 7. So what this tells me is that the coordinate 3, 7 is where these two lines cross on the graph, and the only xy combination that satisfies both of these equations.